So what killed the dynamo? To understand that, you need to understand what makes a dynamo work in the first place. Deep inside a planet, a magnetic field is generated through a process called the geodynamo effect. When electrically conductive fluid, in Earth's case liquid iron, moves through convective currents in the outer core, it generates a self-sustaining magnetic field. It's essentially a massive, planetary-scale electric motor made of molten metal. But that convection requires one thing above all else: heat. The iron has to be hot enough to stay liquid, hot enough to keep moving. The temperature difference between the inner core and the outer mantle has to be large enough to drive the circulation. And heat on a rocky planet is finite. It comes from two sources: the residual heat left over from formation, the energy of all those primordial impacts, and the slow radioactive decay of elements like uranium, thorium, and potassium inside the planet's rocks. Both of these heat sources fade over time. The question is, how fast? And that's where Mars made a mistake it was born with. Mars is small. Not just a little small, half the diameter of Earth, 1/10 the mass. And that size difference, that single accident of birth position in the solar disk, determined everything that followed. A smaller planet has a higher surface area to volume ratio. In simple terms, it loses heat faster relative to how much heat it contains. The same way a small cup of coffee cools faster than a large thermos. Mars, being half Earth's size, cooled dramatically faster. Within the first 500 million years, the heat that powered the convective churning of its iron core had bled away into space. The iron solidified, the circulation stopped, the dynamo turned off. And with the dynamo off, the shield went down.